Good evening, students. Today's topic is isomerism in grade 10 chemistry. In the previous classes, we have done with the exercise 12a. So, in that, we have some questions based on isomerism. So, we need to discuss what is isomerism. So, if you come to the definition, so iso generally refers to something which is similar. If you are taking two organic compounds, in that they have same molecular formula and different structural formula, then you call them as structural isomers, and the phenomenon is known as structural isomerism. See, generally you have two types. First one is structural isomerism and second one is stereoisomerism. So grade 10th we are going to discuss only about types of structural isomerism. Hope you have followed up to this. Now let us see with some examples how to explain the structural isomers. So very simple, you should have organic compounds with the same molecular formula but their structural formula should be different. Those are called as isomers and the phenomenon is called as isomerism. So we have four types here. Four types of structural isomerism. That is chain isomerism. Second one is position isomerism. Third one is metamerism. And fourth one you have functional isomerism. So I'll just give a hint of what is the difference in these isomers. In all these isomers you are having same molecular formula only, but if you take chain isomers, in this arrangement of carbon chain is different. So the organic compounds which are having same molecular formula but the different arrangement of carbon chain are known as chain isomers. Second one, if you see position, here the position of functional group is different. So how do we define position isomers? The organic compounds which have same molecular formula but the position of functional group is different are known as position isomers, and the phenomenon is called position isomerism. Next, metamerism. The arrangement of different number of carbons. So different number of carbons, nothing but alkyl group. The arrangement of different number of carbons, that is alkyl group, on either side of functional group is different. So we shall discuss with the examples, then you will understand much better. I am just giving you first the difference between the four types of structural isomers. So it says that they have same molecular formula but arrangement of an alkyl group and other side of functional group will be different. So we will see with the examples later. Now, what is meant by functional isomers? In this, they have same molecular formula but different functional groups. So these are the four types of functional structural isomers. So let us discuss one by one. First one, So arrangement of carbon chain is different here. So let us take 4 carbon chain. One more example, let us take 5 carbon chain. So if you are writing 4 carbon chain or 5 carbon chain in a linear way or in the straight chain, then it is represented as N. What is N here? N is nothing but normal. So 4 carbons root word but, single bonds, therefore ANE. So it is called as N-butane. Now you can complete the hydrogens. Same way, we have written 5 carbons in a straight chain, hence you can call it as N, that is normal. We have 5, so root word pent, single bond, ANE. Now complete your hydrogens. Now, how do you change the carbon chain? So let us take one branch, that is methyl group, and fix it at second last position like this. So let us write like this, methyl group and complete hydrogens. Fine. Now if a branch is present at second last carbon, so we have one branch at second last carbon, then you use a term called as iso. These are all the common names. So therefore we can write it as iso 4 carbons butane. This is your common name. This is also common name. Now consider the molecular formula for these two. What will be the molecular formula? That is C4H10, 3, 5, 7, 10. Molecular formula of N-butane is C4H10. Now what is the molecular formula of isobutane? Again 4 carbons, hydrogens 3, 6, 9 and 10. Fine. Now we can see that the two organic compounds are having same molecular formula, but what is the difference here? The arrangement of carbon chain. In the first case, you have arranged in a continuous chain, but in the second case, a branch is present at the second last carbon. Hence, these two are called as chain isomers, and the phenomenon is called chain isomerism. Now coming to this pentane, here we can have totally 3 compounds. How can we make 3 compounds? First one, at second last carbon we have one branch. Similar to this, so this can be written as iso. So therefore the name will become isopentane. Now complete the hydrogens. Fine. Now the last one, you can take 2 branches now. This is one branch and this is the second branch. So here we wrote one branch if present at second last carbon, you call it as iso. If at all you are having 2 branches, if 2 branches are present at second last carbon, you call that as neo. Therefore this is called as neopentane. So the word neo. Now complete the hydrogens and just calculate the molecular formula. In all this, if you calculate, the molecular formula will be C5H12 here, C5H12, 3, 5, 7, 9, 10, 11, 12. Now coming to the second one, C5H12 will be there, 3, 3, 6, 9, 10, 11 and 12. Similarly, the third one also C5H12. Now, how to define these 3 compounds? They have same molecular formula C5H12, but the arrangement of carbon chain will be different. First one, you have a linear chain N. Second one branch, so you call it as isopentane. Third one, 2 branches, you call it as neopentane. Hope you have understood the first isomerism, that is chain isomerism. Now let us take second one position. . So what is the difference in chain and position? Now here the position of functional group is different. Let us take any functional group. Alcohol you take. Now the difference between these two compounds. First one, representing the complete formula. So numbering is done from this direction because in the nomenclature, this is the primary functional group, so we will start from this. Again here also numbering is done from this direction. Now the name of this compound, butane dash 1 dash all, this will become butane dash 2 dash all. Calculate the molecular formula. This will be C4 3 5 7 9 10 and O. This is the molecular formula of butane dash 1 all, and second one, the molecular formula will be the same. Now observe these two, they have same molecular formula, but what is the difference between these two is, in the first case the functional group is at first position, in the second case it is at second position, hence they are called as position isomers, and the phenomenon is called position isomerism. You can take any other functional groups also. So one more example, let us take ketone. We will write 5 carbons. So we have ketone. Carbonyl group, on either side you have carbons, hence it is ketone. Fine. Start numbering now from this direction, 1 2 3 4 and 5. The root word because 5 carbons spent. And now single bonds ANE, remove the terminal E and write it as dash 2 on. The suffix for ketone ONE Next, here any direction you can take, and after writing the numbering you will get pentane dash 3 on. So very clearly you can understand that the functional group position is different. Now calculate the molecular formula. Here 5 carbons, 3, 5, 7, 8, 9, 10, H10 and O. This one, 5 carbons and H, 5, 7, 8, 9, 10, O. So in both the cases you have the molecular formula same, but the position of the functional group ketone is different. Hence these are called as position isomers, and the phenomenon is called as position isomerism. Hope you have understood this. Next one, either you can take metamerism or functional isomers, anything is fine. Let us take functional isomerism. Already we discussed the functional group is different. For example, if you have alcohol in the another isomer, you should have ether. If carboxylic acid in one compound, another compound, you should have ester as the functional isomer. If aldehyde is the functional group, another compound, it should have ketone to be the functional isomer. If cyanide is present in first compound, you should have isocyanide. Keeping this in mind, let us write one example here. First one, you have 4 carbons with the functional group alcohol. Whenever you have functional group, that is alcohol, definitely should have ether as the second functional isomer. Therefore, let us write 4 carbons can be written like this. In the first example, 1 on the left and 3 on the right. One more example with 2 carbons on the left and 2 carbons on the right. This is also possible. So now let us complete the hydrogens. So we can write IUPAC names, or you can also write the common names. So here it is at first position, so butane 1-ol. And for this we already know, according to Popov's rule, always the oxygen is given to the less number of carbons or lower alkyl group. So therefore this is considered to be, so 3 carbons, so root word will be prop, single bonds ANA and methoxy. Second one, because both the sides the same number of carbons, you can take it as ethoxy, root word eth, single bonds ANE. So the functional isomers for butanol are methoxypropane as well as ethoxyethane. You can check out, both will have same molecular formula, C4H35790 oxygen. Next we have 4 carbons, H35710 and O. This one is also C4H10O. So hope you have understood. Similarly we can take any other functional group combination also. So here we can say that alcohol with molecular formula C4H10O is having, like here you can see 2 different functional groups, that is ether. This one can be the functional isomer for this one can be the functional isomer for this, and when you check this one, these two will be considered to be the position isomers. So already we have discussed that. Now the last one, so metamerism. So this is very important isomerism. So we have discussed the definition earlier. What is that? The 2 compounds which have same molecular formula but unequal distribution of carbon atoms. Now let us take first functional group, ether. Fine. Here I can get 2 carbons, here also 2 carbons. On the other side I can write 1, because 4 are there, you can mention like this. Hope you are able to understand. We have same functional group, but what is happening is, here you have 2 and 2 carbons on either side of ether, but here unequal distribution is done. Like left side 1 carbon, but right side 3 carbons. So we can observe that there is unequal distribution of alkyl groups on either side of functional group. We have ether as a functional group here. Now counting the molecular formulas here. What is the molecular formula? C4 35710, so H10O. Now C4H3 5 7 and 10 with O. So both the compounds have same molecular formula, but what is the difference? In the other compound you have unequal distribution of alkyl groups on either side of functional group. So here you are having methyl, that is 1 carbon. Here you are having propyl, that is 3 carbons. Now let us change ether and write amine. The same example you can take ethyl group on one side and ethyl group on the other side. Now how to write the metamer for this compound? So unequal distribution of alkyl groups are carbon, here 1 amine NH, and here you can write 3 carbons. So if you check the molecular formula, so already you know about writing the names, so I am not writing the names here. In short, you can say diethylamine, so methyl propyl amine, common names. So now here we have C4H 3, 5, 6, 7, 8, 9, 10, 11 and N. And this one is C4H 3, 4, 5, 6, 7, 8, 9, 10, 11 and N. Now both have same molecular formula, but unequal distribution of alkyl groups on either side of functional group. So first one is ether, second one is amine. So with this we have completed all the 4 types of isomerism. So for grade 10 we have 4 types, and if you move to the higher level we will study 2 more isomerism. Thank you so much.